The question is use partial fractions to determine this integral. So first of all, we want to write whatever is in here using partial fraction. So I want to write this using partial fraction. So I will have 1 over a squared minus x squared. We want to write it using partial fractions. First of all, I can write this in a simple way because this is a difference of two squares. I can write it as 1 over a minus x, a plus x. Then clearly we can see that the denominator is linear. Under partial fractions, you look at the denominator. The denominator could be linear, it could be quadratic, it could be repeated. So this particular one is linear. Now, recall, how do we open up a linear denominator? So we have 1 over a minus x, a plus x. How we open this up is a over a minus x plus b over a plus x. This is going to be our partial form. So what we are going to do is we are just going to look for the values of a such that this holds. So let's first of all put them under the same LCM. The LCM will be a minus x, a plus x. Then we have a into a minus x goes here, we have a plus x. Plus b into a plus x goes here, we have a minus x. This is supposed to be equal to 1 over a minus x, a plus x. Okay, so now we're going to choose random values of x and replace them in the numerator. So I will start with when x is equal to minus, someone said, why not minus a? So in this case, we're going to use when x is equal to minus a and a. I want us to see that we should be able to get the same answer. So when x is minus a, what are we going to have here? If we put minus a here, this will be 0. When x is minus a here, we will have b and then we will have 2a. When x is minus a here, we'll have a plus a. That will be 2a. So we will have 2ab. Meaning our b is equal to what? Directly we get our b being equal to 1 over 2a. Then when x is equal to positive a, replacing when x is equal to positive a, so positive a, we have 1 on this side, is equal to x is positive a here, we have 2a, and then x is positive a here, a minus a, we have 0. So what is the value of our a? Our a is equal to 1 over 2a. So clearly we have the answer for a, we have the answer for b, so we can now write it into its partial form. So we are looking for the integral of, where there's a, we'll write 1 over 2a over a minus x, plus b is 1 over 2a, a plus x dx. And this can be written as, if I factor out 1 over 2a here, I'll have 1 over 2a into integral of 1 over a minus x dx, plus 1 over 2a, I am going to write them under separate integrals, into integral of 1 over x plus a dx. I also want to write this one starting with x and factoring out the negative so that I can clearly see it. So factoring out negative, this is going to be 1 over positive x minus a dx, plus 1 over 2a integral of 1 over x plus a dx. So if you integrate this, you get ln, because if you differentiate x minus a, you get 1. If you differentiate x plus a, you get 1. So here we'll have minus 1 over 2a ln x minus a, plus 1 over 2a ln x plus a, plus c. And that is the answer for that particular integral. Let me know if you guys have any questions. So that is for the second part. Hence, determine the integral from 0 to 2 of 5 over 9 squared minus x squared dx. We've just identified what our a is with respect to the initial question that we were given. This was the initial question, and this was the answer that we got. So if we relate, what we've done is take 5 outside, then identify your a. Your a is 9. So where there's a in the answer, you will replace with 9 and then put the limits. That is it. So that's how you are supposed to go about it. Let me know if you have a question. So the next question is question number 7. Integral of x ln x dx. Integral of x ln x dx. So, guys, we have an algebraic function and we have a logarithmic function. Recall Liate. Logarithmic, algebraic. So, meaning logarithmic should come before algebraic. So, you'll write this in the form ln x x dx. Then let this one be your u and let this one be your dv. And the formula for integration by parts is uv minus integral of v du. Now, we already know what our u is. Our u is equal to ln x. So what is our du dx? If you differentiate ln x, what do you get? You get 1 over x. Then our dv is equal to x. What is our v? If you integrate x, what do you get? X squared over 2. So coming to input these values, uv, what is uv? U is ln x multiplied by v, which is x squared over 2, minus integral of v is x squared over 2, multiplied by du. Now come and see, if we make du the subject of the formula from here, du will be equal to 1 over x dx. So 1 over x dx. This x can cancel out with 1x, you remain with x there. So simplifying this, we have ln x, and then we have x squared over 2 minus, we can take the half outside, we remain with integral of x dx. So this gives, let me start by writing this because I've finished integrating this first part. X squared over 2 ln x minus a half, integrating x, what do we get? X squared over 2 plus c. So this simply becomes x squared over 2 ln x minus a quarter x squared plus c. That is it for that particular question. That is it for that particular question. If you have a question, ask. The next one is question number 8. Integral of 1 over cos x dx. Now, this is directly from your books, guys. We use t is equal to tan theta over 2 substitution. For this particular question, we use t is equal to tan theta over substitution. So go and check in your books. How exactly do you write cos x? In the books, I gave it as cos theta. Then you come replace. How exactly do you write dx? In the books, we have it as d theta, cos theta. It's exactly what we did. It's in the book. So I'll let you guys refer to it from the books. And then the final question in that particular part was evaluate integral of 1 plus tan squared theta d theta. Now, it's important, in order for you to do this question, it is important for you to remember very well your trigonometry. Now, if you recall from the trigonometrical identities, 1 plus tan squared theta is the same as sec squared theta. So we can simply rewrite write this integral as the integral of sec squared theta d theta. And if you integrate sec squared theta, what do you get? Tan theta plus c. If you just check in the table. That is it. That is actually cut 2, not cut 1. So that is it. Those are all the answers for cut 1. It's because we are doing it online. We've taken, I think, about 1 hour. But if we were doing it physically, maybe we would have taken 30 minutes. And the paper said 2 hours. So